All right, folks, we have been doing 5.3.2, which was our angle similarity, and we are doing 5.4.1, which is our side similarity and side similarity. Okay, so the main thing is these triangles are not equal, they're not sitting on top of each other, they aren't congruent because they may not be the exact same shape, size, but they can be similar. So two triangles that are similar might be these two, okay? They're similar because we can prove them similar using these three postulates, okay? These three criterion. Now, angle is gonna be, you have one angle in common, you have another angle in common, all right? Side, we'd have, guess what? We'd have a side in common, a side in common, and guess what else? A side in common. Okay, so we can say that those are similar. Now, angle side, we have, let's make a triangle like this, a little bigger. Angle side has a side in common, an angle in common, and another side in common. Okay, so these are the three different options that we have right now. Side, angle, side. Looking at the tick marks, how they correspond, sides, all the sides are the same. Angle, we just need two angles in common to show that they're similar. All right, so these are the three different ways we're gonna show triangle similarity. And then what are we gonna do with that information? Let's look at a couple examples. So here's one triangle, here's another, okay? So first off, let's just look. What if I have these two angles in common, and these two angles are also congruent? We know that it is similar by what? Angle. Now, again, we have angle, we have side, we have side, angle, side. Okay, so if you have the criterion for any of these, then the next steps are going to be exactly the same. Okay, because look, if I have, this is 5, this is 10, and I know that this is 6 and this is x, how would I find what x is? Okay, now if it is similar, and that's what the symbol means, similarity, similar. If it's similar, that means that the proportion, this 5, which corresponds to 10, that difference, that being, we could see it's double, twice as big, is going to relate to 6 and x because those two are corresponding. Now what I suggest is, use your pencil, you can do it with a square or a circle. So 10 corresponds to, let's look, the tick mark's 1, tick mark 2, tick mark 1, tick mark 2. So I know that 10 and 5 have to correspond, okay? The other option, or the other places, we have 6, which is to the right of our two consecutive congruent angles. So it's 6 is here, x also corresponds. So these are set up easy because it's the same orientation. If this was flipped, you just have to be careful and use your tick marks to make your way through this, okay? Now, we are gonna set up a proportion. The proportion is going to have the same triangle here. So we'll put the small triangle on the top, the big triangle on the bottom. And each fraction consists of the corresponding parts. So I would never have one fraction that had 5 and 6. It wouldn't be 5, 6, because remember, each fraction has to be the corresponding parts, and 5 corresponds to 10. So I'm gonna go in here and I'm gonna put, let's see, 5 and 10. Small triangle 5, big triangle 10. And then I'm gonna go in, and for the other corresponding part, 6 and x, I have to make sure that the top numerators are from the same triangle, the smaller triangle. So instead of 5 here, the same triangle has 6. The corresponding side in the larger triangle is x, okay? All right, let me try to get that sharing again. Really too bad. All right, I will try to explain that quickly again. All right, so the first fraction is the corresponding parts. I keep the small triangle values on the top, the large triangle values on the bottom. So I've created our proportion, our ratio here. Now I need to cross multiply. We get 5x is equal to 60. We divide by 5. We get x is equal to 12. Done. And that's how we're going to approach every single problem. First, to see, here we had angle, but if it was side, or side, angle, side, as far as the congruent sides between similar triangles, then we know we can just set up a proportion. And that's the basic. Really, that's for the week. That's how we're going to be approaching everything. I know that this side right here is equal to 12. If this was an expression like x plus 1, I'd plug in 12, add 1, to give you 13. All right?